So to answer the questions, were there timing differences between the code where it's all in one source file and when it's in two different source files? 1.8 times difference. Okay. So there was some exposure, it could see some optimization opportunity. With both compilers or with one? With both. What did the vectorization report say? Did it tell you something about multi-versioning, for example? Okay, so it was what we were saying earlier about two pointers coming in. Well, the function can see is it knows two memory addresses are coming, then it treats them as arrays. But it doesn't know what those memory addresses are going to be. So it could be that they're completely separated. It could be that they overlap. It could be that, like that example we had with a real dependency of A equals A plus A minus AI equals AI plus AI minus 1, that could occur as well. It doesn't know what's going to happen. So it will throw out multiple versions of the loop, and then it will see what happens actually at runtime, and put in some complicated checks to see, well, where are these things? Then you had a chance, hopefully, to use the minus guide option, and it would throw out a nice big paragraph at you with one or several options. And if you implemented the advice, did you get a speed up? No? Yes? No? Some people did, some people didn't. Okay. What was the advice? Was it to put in a pragma? You said put in restrict. Some people may have done that. Did it also suggest a pragma or not? Or am I on the wrong example? Sorry? Pragma loop count. Okay. So there were options there available to you in this particular case. And you could get a speed up if you followed the advice. So that's great. Not only does it tell you that it can't do something, it also says, but if you help me, then I can help you back. One of the things that comes in there, one of the options, hopefully it would have reported, was maybe IVDEP. So there's this set of compiler directives, and for example, for the Intel compiler, just look on Google for Intel compiler directives, and then click on the first entry, and it will tell you then will get a list of compiler directives. It may not actually be the most up-to-date one, but it gives a good set of these things. So the IVDEP compiler directive is one that's been available in a whole host of compilers for many, many years now, and it's saying to the compiler, if you see vector dependencies, ignore them. I'm telling you there won't be any. I'm making a commitment. And if I'm wrong, then that's my fault and I'll get the wrong answer. Okay? But it's very powerful because you're just overriding the optimizer's attempt to help you. And often it will be conservative. Compilers generally try to be conservative in a lot of what they do because they don't want to get things wrong. They don't want to give you the wrong answer. And they don't want to slow your code down by making optimizations that are no use. So check that compiler set of compiler directives in the documentation. Two useful ones are IVDEP and vector always. IVDEP, if you know for sure, there's no problem. And vector always is something that actually the compiler can still ignore, I think. It's basically saying, you really should be doing this, you really should be vectorizing, but it's not an absolute strict statement. There's another one that don't put on here, which is even stronger, which is hash pragma SIMD, and that effectively rolls these into one and says definitely do SIMD vectorization. But maybe somebody from Intel actually has more information about the inner workings of that and how powerful it is. So we've seen these things mentioned already, dependencies, and sometimes a compiler can have difficulty vectorizing if it sees a dependency between some statements in a loop. These dependencies inhibit vectorization, as you've already seen, but it's the major job that you're going to have if you're using C or Fortran or C++ in a standard way and just hoping that the compiler can vectorize for you. because it will just start spitting out dependencies all the time for you to deal with. You may get help with the minus guide option, but you may not. I just thought one reason why, I don't know whether minus guide, if you put that on, whether it actually doesn't give you an executable. So that might be why. I'm not sure whether you have to recompile again afterwards. Right, okay. So there are a large number of these dependencies we could block compiler. We don't have time, as I said, this is a short course, to look at anything really more than one. So we look at one, vector dependency, and again, see whether we can get out of this or not. And see whether there's a difference between different compilers with a vector dependency. So the last of these little practical sessions for the morning is there's another directory, this time forward, for forward dependency. Intel and GNU, vectorization mode, run the executables, timings, etc. And then you should see a difference between the two compilers, but I'll leave it up to you now to guess which one would actually be the one that can and which one can't. And then for one of them, you may be able to do something if you make changes to the loop structure.